So neutron interactions, section 4.3.1. And it says, if you read along, it says neutrons have no electrical charge, and that neutrons have about the same mass as that of a proton, that they're much larger than that of an electron. But here's important. It says neutrons may collide, or in other words, interact with certain nuclei, causing one of the following: elastic scattering, inelastic scattering, radiative capture, or fission. So this is our capture, fission, and our two scattering events. Let's look at scattering in more detail, because remember, we had two types of interactions that the neutron could have while it's scattered. It could be elastic in nature. So let's look at that. Elastic scattering. Elastic scattering. A neutron comes in. And let's just say it's coming in with a certain amount of energy, and let's say it interacts with a water molecule. Well, I know that a neutron has about the same mass as hydrogen in this water molecule. So what I'm going to do is take this and break it up into two hydrogens and an oxygen. So, if the neutron were to come in and interact with the hydrogen here, since they have about the same mass, think about billiards or bowling balls. If a bowling ball hits a bowling ball, it gives off a lot of its energy, and it will actually slow the neutron down and impart some of that energy to the water. So this water, if I was to get an elastic scattering event, what's going to happen is the neutron is going to hit the water molecule, interact with possibly the hydrogen. What happens is the neutron goes this way with a lower energy, and it has imparted some of that energy to the water. And in this case, whatever kinetic energy this neutron started with, energy due to velocity, the same energy exists, but now this has a lower kinetic energy than it initially had, and this has a higher kinetic energy than it initially had. So essentially, the water is slowing down the neutrons through elastic scattering, giving off some of the energy to the water itself, ever so slightly. That's going to be a pretty important event that occurs in our plant. Very important. So elastic scattering essentially can say kinetic energy is conserved too, because the kinetic energy here is just split amongst the water molecule and the neutron, and it should essentially be equal to the same kinetic energy that was there. Now that's quite different than the next one. So we'll look at inelastic scattering in the next one.